Mm. All right, welcome everyone. Going to give everyone just a few moments to join, and then my colleague Helen, who's here with Acelab, will give a quick little introduction, show you guys how to find today's presenters on Acelab, as well as give you a sneak peek of some of our newer tools. And then we'll go ahead and get started with today's CEU course. All right, looks like we got a good amount of folks in. So Helen, feel free to take it away whenever you're ready.
Sounds good. Thanks, Bo. Hey, everyone. All right. Today I'm going to show you a couple things. Can you all see my screen?
Yep.
Perfect. Great. First things first, let's talk about how to find O'Keeffe's and get in touch with them and what y'all can expect after this webinar. So anytime you're looking for any brand, you can always type them in up here. And once you start doing that, just make sure you have brand selected. It will kind of pre-select for you. It doesn't look like there's a lot of other categories or resources that start with O'Keeffe's there. So this one's pretty easy. So then we'll select their page here. What this allows you to do is see an overview about the company. You can request information, get in touch with them here. And then also all of their products are here. And what you can then do is save the ones that you're interested in to your projects. You can create comparisons from there as well. So lots of things. You could also don't ever forget this little see more button. So you can make sure that you have the right ladder for your project. Again, lots of options there. And then here's some photos additionally down below. So lots of good info on the page, and this is a little bit about the company as well. So this is a great way to connect with that team and also, again, save some of their products into your projects. And I'll get into that here in a moment. Other thing to note is that after the webinar, depending on what you complete in the poll, we will start a conversation for you within Acelab with the folks at O'Keeffe's. So you'll see that when you log back into your account, you'll see this conversations icon with a little notification there. You probably won't have 287 messages. That's just for me. And the other thing I will say on that too is that you'll get an email as well when we've kicked off that conversation. You can respond directly from your email and ask these folks any questions that you may have. So that's a little bit about what to expect here. What I might do actually quickly is I'm just going to save some of these into my general research folder. And now I'm going to jump into that project. And I just want to show y'all what the comparisons feature looks like, and then also what we have coming out down the line. So here we go. Going to jump to their products here. So I saved those in. What we get is this nice little comparison feature. Specs, CAD, BIM, they have those available as well. So you can download those files directly here, and just additional brochures as well. So it's a nice spot to kind of keep a record of everything. Speaking of which, that's what this schedules feature does. Lots and lots of options here. People are using this all kinds of different ways, but the whole idea is that you are able to generate your schedules, also share different views of all the products that you're thinking about and selecting on a project basis. And then the last thing I'll share with y'all too is that something that's really fun is also looking at Acelab for your kind of material hub purposes. So what this allows you to do is basically keep all of the products that y'all use frequently, want to use frequently. All of these columns are custom to y'all, so you can make these as many columns as you want. But it makes it really easy when you start a new project to just say, hey, I'm going to take these two products and we're going to copy those over because these work well in, say, X, Y, and Z climate zone. So there's a wide variety of uses for all of this, and I'm here to kind of help guide you all through that. So I'll pop my meeting link in if you want to talk further about this. We would love to chat with y'all about it. All right, that's all from me.
Thank you so much, Helen. Yeah, feel free to book a meeting with Helen to learn some more, or respond yes to the poll we've got up now, and we'll reach out to set up a time for you to get started with Acelab. Other than that, just want to encourage folks to please submit any questions to the Q&A throughout today's presentation. We've got Adam on here. He's the ladder expert from O'Keeffe's. He's going to be helping out with answering some of today's questions. And Michelle Murray is going to be presenting today's CEU course. We did ask for AIA numbers upon registration. We will also send over a form in the chat momentarily where you can submit your AIA number and request a certificate in case you are worried you haven't done that yet. All right, I think that is all for me. Michelle, whenever you're ready, feel free to share your screen and get started.
Okay, thanks so much for the introduction and the opportunity to share ladders with you. Mm. Okay. Can you see my screen?
Yep.
All right. So today, first I'll just introduce myself. My name is Michelle Murray. I work for O'Keefe's and Safety First, and this is just one of our divisions here at O'Keefe's is our aluminum ladders. And just a little housekeeping, this is an AIA accredited presentation. So moving forward, I will try very hard not to use O'Keefe's or reference us as a company. It's copywritten. So we're going to have 4 learning objectives today. We're going to look at the different materials that are currently used for ladders, looking at the pros and cons of each. We're going to study codes and standards and understand how design and specifications of ladders are used based on the application. We'll also look at some of the standard and custom ladder options, and then look at some case studies and some real projects in real world settings. So our first objective is to look at the different types of materials used for ladders and their pros and cons. So currently on the market, you have wood ladders, fiberglass, steel, and aluminum, and they all have some strengths and weaknesses, and we'll kind of go through those. Wood ladders are also called timber ladders, and it's a very popular choice basically because it's affordable and readily available. As long as you take proper care of them, wood ladders can last a long time. When they're dry, they're also a non-conductor of electricity, and it makes it a good choice for environments like that, along with fiberglass, if you have electrical hazards. Despite this, wood ladders aren't appropriate for all industrial and commercial environments because they are prone to rot, fungus, mold, and pest. Another popular choice is fiberglass or an FRP, which is a fiberglass reinforced plastic. So it's a composite material made of glass fibers and a polymer resin. Among the different ladder types, they're considered to be the newest. They're lighter than wood, but heavier and denser than aluminum. They're also non-conductive, and they are corrosion resistant. In comparison to aluminum ladders, fiberglass ladders can be more difficult to work with because of the weight. Also, setting installation difficulties aside, the high cost of fiberglass also is one of the biggest disadvantages. Steel is a great choice for a rough environment, such as a warehouse or an industrial facility, but it's important to note that steel ladders are not corrosion resistant. If you plan to install it outdoors, you'll need to have it galvanized, painted, or made with stainless steel to meet ladder regulations, and this can add to the ladder's expense. Aluminum ladders are very popular in commercial and industrial applications as they're durable, lightweight, and affordable. Moreover, you don't need to worry about maintaining aluminum ladders because they are a corrosion-resistant material. So we're going to look at some of the difference between aluminum and steel in ladder fabrication. Aluminum is a lightweight, high-strength material, while steel ladders tend to be heavier and makes them difficult and expensive to transport and install. Aluminum is resistant to rust and corrosion, while steel ladders can rust over time and may eventually need to be replaced, which adds to the cost and maintenance. In addition, if a rusting ladder is not noticed or attended to, it can present a hazard to anyone who attempts to use it in a corroded state. To combat corrosion, steel ladders are either galvanized or painted or made with stainless steel, and that would add cost to an already expensive ladder. Aluminum ladders are also maintenance-free, thus lowering their lifetime costs and improving their lifetime dependability at the same time. Aluminum is non-spark, reducing the risk of being a fire hazard. It's also non-magnetic, making ideal in places where magnetic equipment is stored. Aluminum ladders are available in multiple finishes. They can be painted, anodized in clear, bronze, or black. without losing its shine or color. Steel can be painted, but it cannot be anodized. Top quality aluminum ladders have deeply serrated square rungs for maximum foot traction, comfort, and safety. Steel ladders typically have round rungs and are not serrated, making it less stable and potentially slippery for the person using it. Aluminum is also environmentally friendly. The top manufacturers make aluminum extrusions with recycled content, and a ladder can have as much as 26% post-consumer recycled content. Aluminum is also most infinitely highly recyclable. So if a building is demolished or altered, the ladder can be recycled once again. So we're going to move on to codes and standards, and this gets a little bit wordy. I'll try and leave the slides up a little longer so you can read some of it. We're going to learn about the relevant codes and standards relevant to not just the design, but also the specifications and making the ladder usable in the appropriate application. So these are some of the commonly referenced codes and standards. There are a number of codes and standards and authorities which may govern and inform the design and use of ladders. So designers should always check to see which codes and regulations apply to specific projects, since rules vary from place to place. And also remember that codes set minimum standards and that exceeding the codes is simply best practice. Even when a code or a standard may not be legally applicable, it can contain valuable design advice that can be used to ensure ladder design is safe and trustworthy. A lack of understanding of code requirements can lead to flawed specifications, installations, which in turn can pose a dangerous situation that would have to be remedied at the cost of money, injury, or loss of life. So the IBC is probably one of the most recognized building codes. It contains regulations about practices and use in commercial construction related to all buildings except 1 and 2 family dwellings. When it comes to these IBC codes, it's going to be a differentiator between occupied and unoccupied roof. And for this presentation, we are going to focus on the unoccupied roof. So an occupied roof is considered something that's accessible to all building occupants. Examples would include like a rooftop lounge, a pool, or a gathering space that is accessible to the public. It's considered a story within the building, like any other enclosed story, and therefore the means of egress would apply. An unoccupied roof is accessible only to maintenance or construction personnel. That means anybody servicing or doing roof repairs or maintenance, or any mechanical equipment on the roof. So again, a little bit wordy. The IBC indicates that permanent ladders are not allowed as part of the means of egress, but they can be used to access these areas. So if you're doing maintenance or repairing of equipment, if you are in a space that is only accessible by a catwalk or a crawl space, non-occupied roofs that are not required to have a stairway access can use these ladders as means of egress. So again, in unoccupied spaces, this is where ladders can be used as the egress. So OSHA stands for Occupational Safety and Health Administration, and the importance of OSHA lies in its ability to protect workers from potential hazards and risk in the workplace. So OSHA standards are rules that describe the methods employees are legally required to follow to protect their workers from hazards. ANSI stands for the American National Standards Institute. They do not develop the standards. It establishes a context for them to be created by standards developing organizations. ANSI standards, however, can be adopted by OSHA and thus become the law.
What is the difference between OSHA and ANSI standards? OSHA standards are mandatory and regulate how employers must provide safe working conditions in the workplace. ANSI standards are voluntary and are related to the products used and to the general consumer population. ANSI standards may be adopted by OSHA as law. Applying both types of standards lead to fewer injuries and deaths and an overall better workplace environment.
Okay. I don't know if my video froze up there. So we will move on to learning objective number 3, which is looking at the available options and accessories that designers can use on ladders today. You'll find metal ladders in the Division 5 of the CSI master format under the metals, and these are just some of the areas that you would find what we're going to be looking at. So a good quality aluminum ladder would be made with lightweight, corrosion-resistant aluminum. It's going to be non-spark, high strength. The hardware will be all stainless steel. The serrated square rungs for maximum strength and safety, and then standard mill finish, but can be anodized, painted, or powder coated, usually for an additional cost. These are the most common types of ladders: the fixed access, the cage ladder, and the ship ladder, also referred to as ship stairs. Other common applications include stairs, extended platforms and catwalks, which we'll see in our case studies, and ramps. So fixed access ladders are permanently attached to a building or structure in order to offer safe, continuous, and easy access to rooftops, mezzanines, loading docks, and rooftop hatches. There are several aspects to be considered when in the need of a fixed rooftop ladder, including access points, safety features, durability, and maintenance. A roof access ladder should be both accessible and functional, customized to your exact space and needs with safety features like stainless steel hardware and fall protection systems. They should be built to resist rust or corrosion over time, especially in applications where they are exposed to the elements. This is just looking at the anatomy of a fixed access ladder and what they all share in terms of features. They're all going to have rungs, side rails, and brackets. And depending on your application, the brackets can vary, the side rails and the rungs can also vary. Some fixed access ladders have roof over rail extensions. Some will have a platform with a return. Some platform without return. On code parts of the fixed access ladder, there are slight differences between OSHA and ANSI. For the rung spacing, OSHA is going to be between 10 and 14 inches for spacing, and for ANSI, it's going to be 14 inches. For the rung width, OSHA and ANSI require 16 inches minimum, and for the IMC, it is 18 inches. On the side rails, OSHA and ANSI require the rails to extend 42 inches, and for IMC, not less than 30 inches. For grab bars, OSHA and ANSI require a clear width of at least 15 inches. For a backside clearance or a back set, OSHA and ANSI require 7 inches, except for elevator pit ladders, which is a minimum of 4.5 inches. The little bit busier slide on the left, you'll see the normal clearance, for that's the climbing side clearance. So OSHA, ANSI, and IMC all require 30 inches minimum. And for the side clearance, OSHA, ANSI, and IMC require 15 inches. When it comes to ship ladders or fixed ladders, 75 to 90 degrees from the horizontal is the pitch that you can have for OSHA, ANSI, and IMC. When you're looking at the load on the rungs, OSHA and ANSI require 250 pounds. IMC needs to withstand 300 pounds. So we're going to move on to cage ladders. Gets to be a little more tricky, as cages aren't permissible as a means of fall protection for any new ladder over 24 feet. If the ladder is under 24 feet, a cage may still be used as fall protection at this point. By November of 2036, all ladders over 24 feet must have a ladder safety or fall arrest system. So a cage or a well is an enclosure mounted on the side rails of a fixed ladder or fastened to a structure behind the ladder, which surrounds the climbing space. You're looking at a picture or a graph of a length of a climb 24 feet or less, where a cage, well, or ladder safety system is not required. Fall arrest systems, which would be used in lieu of a cage. These are typically a cable-based system with a shuttle that connects to a worker's harness D-ring. The shuttle moves with the worker as they climb up or down the ladder, and if the ladder, if the climber slips, it engages the cable and it stops the climber's fall. So this fixed ladder has that system. So a fall arrest system, a rail and harness with a shuttle that connects to a worker's harness. Again, this is what would prevent the worker from falling. Safety posts are an option, and this allows assistance for the climber to hold on to as they pull themselves through a roof hatch. OSHA requires landings for climbs longer than 50 feet. So if there's no fall arrest system, they are placed at every 20 feet. Landing platforms can be used for various purposes, including switching from one ladder to another when the ladders are offset, or they can be used as a resting place in the longer climbs. And a security door prevents the unauthorized access to the ladder for security purposes. The length of climb 24 feet or less with an elevated access, a cage or a ladder safety system is required. So anything, even if it's off the ground, this will require a cage or ladder safety system. A single length climb of greater than 24 feet will require a ladder safety system. If the climb is greater than 24 feet, a platform and a ladder safety system will be required. The the OSHA landing requirements you can see on this figure here. Both fixed access and cage ladders can be specified with a number of options that further improve safety as well as the ability to perform certain tasks. These options can include floor-mounted brackets as a standard, off-floor mounting brackets can be used when obstructions are present that prohibit the ladder from being attached to the floor. In this case, the ladder is attached securely to the wall. An extended intermediate bracket would be a bracket for a backset beyond the standard 7 inches. Additional intermediate brackets provided every 10 feet to anchor the ladder securely to the wall. And we're going to move on to ship ladders, also known as crossover, because they can be configured to cross over equipment or roof to roof. What you see there is a ship ladder with a platform and return. Looking at the anatomy of a ship ladder, all of these will have the same features, including handrails, side rails, treads, and mounting brackets. These are roof over rail extensions, and they provide easy access for mezzanine access with no existing handrails. It's a platform without a return. A platform with a return. This is roof to roof or crossover to access over pipes, ducts, or equipment. Going back to some of the standards, the tread depth, IBC sets strict standards for how ship ladders can be used as a means of egress. Handrails must be provided on both sides. The treads must be a minimum depth of 5 inches, and the risers can be a maximum height of 9.5 inches. The tread depth for OSHA is 4 inches, and the IBC is 5 inches. Tread width for OSHA is 18, and minimum for IBC is 20. For OSHA, the rises can be between 6.5 to 12 inches, and for the IBC, the maximum riser height is 9.5 inches. Handrails are required for both OSHA and IBC. The slope needs to be 50 to 70 degrees from the horizontal. For the OSHA and IBC, the clearance is at least 6 feet 8 inches for overhead. And OSHA needs to be a concentrated load of 1,000 pounds. For IBC, those requirements can vary, and I would highly recommend looking at the table in the IBC code to make sure that the ladder you're designing meets the applicable loads. And finally, ladder colors. All the ladders can be ordered in a wide range of colors. They can also be painted in custom colors. So those are just some of your standards. And finally, we're going to look at some real world settings and some projects in our case studies. This is a custom rolling stair. It's installed at San Francisco International Airport. If you're ever in the Delta terminal, go ahead and look up and you'll see it. This is a custom rolling stair. It needed to go across a skylight, so it needed to be lightweight and high strength. And it's right on the San Francisco Bay, so it needed to meet corrosion resistance. So this was the perfect application for an aluminum rolling stair. The Brownsville Public Utilities Board service yard. This is where they wash their service trucks. So the ladder needed to be durable and it was going to be in a moist environment. This is a custom ship ladder with extended platform. This is the Broadcom building in San Jose. The platform's 35 feet long, guardrails on the side because it's used to maneuver around equipment. Another custom ship ladder with extended platform. This is a pharmaceutical laboratory, and they needed to be 48 inches off the ground to clear pipes and other obstructions on the floor. Because it's a sterile environment, aluminum was the right choice because of frequent washing and sanitizing performed in the facility. This ladder also met all the OSHA and ANSI standards for this application. This is a custom aluminum crossover ramp. This is actually shown in the factory prior to shipment, and it was a ramp because they needed to be able to move equipment around on the roof. The guardrails were there for safety, and this also complies with all OSHA and ANSI safety standards. This is a crossover ship ladder. This is an example of a platform because it is going from on top of a parapet over to another rooftop. This is a custom ship ladder with a platform. This is the Big Fork water tank in Big Fork, Montana. It's 35 feet tall overall. They needed an easy way to access the water tank. This was designed by the Big Fork Water District, and we worked with them on engineering and calculations were provided. The midspan supports have cross bracing that provide additional support for the long span. This was shipped in 3 sections, 2 ladders separate and 1 platform separate. This is a custom ship ladder with a custom ramp for the Lincoln High School in Kent, Washington. They needed a way to access the other side of the light well, which is 50 feet long. A custom ship ladder with ramp was provided because the angle is shallow. The ramp side has ridges to prevent slipping. The ladder has treads, and the handrails are provided for safety. O'Keefe's provided all the structural calculations for it. This was shipped pre-assembled for ease of installation, the ramp in 1 section and the ladder and platform in 1 section. This is the Twin Valley Behavioral Health in Columbus, Ohio. Because of roof warranty, no anchoring was allowed to be done to penetrate the roof. So instead, we provided these 30 these are mounted on the wall, and there's a truss system anchoring to the concrete steps instead of to the roof. These were shipped pre-assembled for ease of installation. The ladder part was assembled on site and craned to the roof. Okay, this concludes this CE portion of the presentation. We do have a little bit of information about our company that we'd like to share with you.
Seems like the video might be frozen, Michelle.
I don't know.
Oh, there we go. Moving
Okay.
now. But I am not hearing audio if that's
Okay. It's not doing the audio again. Is it now?
still no audio.
Oh, well, I don't know why it's not. We tested this earlier.
If you want to try stopping sharing and resharing, and in the interim, we can go through some of the questions.
Okay.
All right, cool. So let's start out with one. And then, yeah, maybe Michelle, if you try resharing and like optimizing for a video clip, that might work.
Okay.
All right, so just a reminder to anyone who hasn't submitted a question, feel free to do that to the Q&A now, and we'll have some time to get to those live. Let's see, starting off here, are aluminum ladders typically galvanized, and is galvanizing aluminum redundant since it's already corrosion resistant?
We do not galvanize for extra resistance. What we would do is offer a clear anodized finish, which is similar to that without the zinc.
All right, great. Are offset ladders with landings sufficient as a means of fall protection as long as the ladder heights don't exceed the code maximums?
Yeah, so in a situation like that, what's going to happen is if you're within 10 feet of a drop greater than the requirement, then a fall arrest system would be required. So let's say the lower ladder is 20 feet, 25 feet past the, or 5 feet past the platform. The next ladder would have to still be under that 24-foot requirement since you're so close to that greater drop. So typically in those situations, you would still need the fall arrest, at least on the upper portion of the ladder.
All right, great. Can you tell us a little bit about what your design support looks like for custom ladder solutions?
Design support. Is there any way to elaborate on that question or add context to it?
Yeah, so I'm guessing just like maybe if you could talk a little bit about like what the collaboration process looks like, if an architect has like a very custom need, do you like have drawing support, or yeah, kind of how do you work through that with an architect?
Yeah, we would probably supply them with similar details pertaining to conditions that are equal to what they have out in the field. And then we would at least let them know how to specify the project. So that way, when the contractor or subcontractor does come to order it, we will include the job specific detailing, job specific engineering, and then that way we can accommodate all the conditions that they have out in those fields.
Awesome. All right. And then I guess kind of in that same vein, is there any type of like on-site support or like installation support for complex or more custom systems?
We don't. We are a manufacturer only, so all the install would be done on site by others. We can absolutely, have some kind of phone call or Zoom meeting set up to go over the materials and how they need to be installed. But we don't actually have anyone who attends the sites.
All right, great. Let's see. Looks like we went over that one. Okay, this is an interesting one. Are there any like common mistakes or oversights that you feel like you've noticed architects making when specifying fixed ladders, or like maybe any certain areas where architects aren't thinking of specifying fixed ladder systems and they should be?
Yeah, I think mostly the mix-ups are on the models when they specify them. Sometimes it's a interior ladder, but they'll specify an exterior ladder. So in cases like that, we would base it off what the picture shows because that's ultimately where they want the ladder. So we would just kind of correct it as they come.
Mhm. All right, great. Looks like that might be most of our open ones for now. Michelle, did you want to try out that video
Yeah,
share?
yeah, I'll try it one more time.
And
I
if
did
anyone
optimize it.
has questions, feel free to throw them in now. We're going to see if this video will work for us.
I don't know which one I should share now. No. No sound. All right.
The sound, which is interesting.
Yeah, it's okay.
All right, well,
Yeah,
I will share
sorry.
everything real quick, maybe. We did throw a link to this in the chat, but if you're interested in learning some more about O'Keeffe's products specifically and about their company, grab the link from the chat on Acelab and we can show you that real quick. Here we go. Okay, so in case you missed the quick intro at the beginning that Helen gave, everyone on this webinar has a free Acelab account. You can use the search bar at the top to search for any brand name, type that in, head over to their page on Acelab. From here, you can view some more about the company. You can see their products, save them to your projects. This is a great place to come and get an idea of the different models that are offered, as well as get in touch with their team directly so they can help you out with making sure you're specifying the correct one here. And I wanted to jump in to show you a little bit more about what you can access on these product pages. So if you're looking for CAD files, BIM files, specs, you can download all of those super easily from Acelab by just heading to any of these product pages. There'll be buttons right here at the top to download those. You can scroll down and view some more product descriptions, as well as some additional downloads down here. So warranties, construction details, all of that good stuff. So this is a great place to come after today's webinar if you're interested in getting some more of that material to investigate some of these systems a little more closely. And if you need any support in doing that, Helen's meeting link is also in the chat, so you can grab that and she can show you how to use all of this information to your advantage. All right, looks like we do have another question that came up. At what height is a crossover stair required for crossing over a low parapet or ducts?
Adam, you're muted.
Yeah, I saw that. Say that again?
At what height is a crossover stair required for crossing over a low parapet or ducts?
Well, when you're coming back down let's say a roof over a parapet wall, they don't want that step to exceed the OSHA step of 14 inches. So in a situation like that, any parapet wall that's over 12 inches, then we would include a step back down. As far as crossing over, you know, you don't say it would apply same with the 14-inch rule. If you're trying to step over a pipe, you're gonna need a climb platform and return so that you safely step over it. They wouldn't want you to have something to where you may climb up and over and then take a large step to try and get back down. So typically anything over 14 inches is a good rule to have one.
All right, great. Awesome. And then, okay, I know you had mentioned that the finish options like that you can select from a wide range of colors. Possible to do like a fully custom color finish option?
Yeah, we have a RAL color chart. It's Tiger Drylock powder coating. They offer a wide range and variety of colors. They also do offer matching. So when things come up where, let's say that they want to match a building, depending on how fine-tuned it needs to be, we are able to match those colors.
All right, great. Awesome. Well, it looks like that might be the last of our, oh, one more. Could you speak on the difference between anodizing aluminum versus galvanizing steel?
Well, they're both a dipped process, but galvanizing is, we're able to order our materials in a anodized material so that we don't actually have to send it out every time. When ladders are welded, we aren't able to use the materials pre-anodized. But the difference between the anodizing and galvanizing is the zinc coat. You're gonna get zinc coat when you galvanize. But as aluminum is already corrosion resistant and lightweight and durable, we don't necessarily need to galvanize them. It's a little overkill, but the anodized coat will do the same thing.
Mhm. All right, great. Cool. Looks like that might have actually been our last question. So I'll give everyone a few more moments. If you have any questions that come up, also a reminder to grab some of those links out of the chat. We've got the link to the O'Keefe's page on Acelab, Helen's meeting link. So feel free to grab anything there that might be helpful for you after today's webinar. There will be a quick post-event survey. So if you have any questions that come up as you're kind of jumping out of today's webinar, or any comments for our presenters, we would love if you could take a moment to fill that out. Super helpful for us to hear some of your feedback and be able to keep bringing you content that's relevant to you and your projects. All right. Awesome. Well, if there are no more questions, Michelle, Adam, is there anything else that you wanted to add before we jump out today?
No, I think that's it. Sorry, the video couldn't, I mean, I'd play the video, but it doesn't make a lot of sense without sound. So
Okay, all good.
apologies for that.
If folks have some more specific questions about, the O'Keefe's company in general, yeah, feel free to,
Have them to reach out.
you can get in touch with their team. We'll
Sure.
help you in touch with them so you can learn some more about their company specifically. All right,
Great.
awesome. Well, thank you,
you.
Michelle, for a great presentation.
Yeah,
Adam, thank you
Thanks
for
for
being
having us.
questions.
Absolutely, thank you.
Thank you. Bye-bye.
Bye, everyone.
Bye.